Welcome to class. Today we shall be looking at laws of electrolysis given by Faraday. The two laws, we have first law and the second law. Before now we have established the fact that substances are actually released or given out as neutral substances at both the anode and the cathode after the electrolysis or after the electrolytic process. It's also a fact, it's also been established, we have equally also seen that inside the electrolytic cell, at the end of the electrolytic process, you still have chemicals, because you must determine the nature of the electrolyte at the end of the electrolysis. Now, in the first law, Faraday's first law of electrolysis, he was able to determine the relationship between the quantity of electricity that is being passed across and the mass of these substances deposited at the various electrodes. In his experiment, he found out that the more the quantity of electricity that is being passed across the electrolytic cell, the more the quantity of these substances deposited at the electrodes, especially at the cathode. For example, we know that during the electrolysis of copper 2 sulfate solution, this is the electrolytic cell again. I have the anode, positive. I have the cathode, negative. I have the source of current. Then the flow of electron is this way. The flow of electron moves out from the anode. This is the anode. And this is the cathode. And this is the electrolyte, which is copper sulfate solution, aqueous. Right? Now, the anode is made up of inert electrode. We are not using concentrated active electrode. So we are using, this is made up of graphite. Also, the cathode is also made up of what? Graphite. So the nature of the electrode is not going to have any effect on this. Now, normal electrolytic process will take place. We know that when we carry out electrolysis on this particular electrolyte, we know that we shall be having copper 2 and hydrogen ion at the cathode side, because cathode is negative. This is 2 that will migrate there. While SO4, 2 minus, and the OH minus, which are negative, will go to the what? Anode, which is a positive electrode. In as much as the compound is not concentrated, in as much as the electrodes are inert electrodes, the factor that will bring or will tell us which ion that will be discharged is the position of the ions in the electrochemical series. So looking at copper 2 and hydrogen ion, copper 2 or copper is less reactive than hydrogen. That means at the cathode, what do we have? At the cathode, the reaction is what? Cu2 plus, which picks up 2 electrons to become neutral copper. That means at that particular cathode, you have copper deposited here. Copper will be deposited here. Okay? Now, why at the anode, OH is discharged because it's dilute. It's a diluted compound. The compound has been diluted. So, in other words, at the anode, we have 4 OH minus, giving us 2 molecules of water plus 1 mole of what? Oxygen, then plus 4 electrons. Now, why am I writing these equations again? This oxygen now is deposited at the anode. So at this anode, you see bubbles here, oxygen gas, which is a colorless gas. While at the cathode, at the end, what is produced is the what? Copper. What exactly did Faraday do? Faraday discovered that the mass of this copper you can find at the particular electrode, which is cathode. The quantity is proportional to the quantity of electricity that is passed across. Do not forget that electrolysis is the passage of current through an electrolyte, right? It's a process by which a compound known as electrolyte, ionic compound, decompose, process by which is decomposed by what? The passage of what? Current. Where we simply define it as what? Chemical decomposition of what? Ionic compound, which is electrolyte, by the passage of what? Current. Now, Faraday moved on to find out the relationship between the quantity of electricity that should be passed across and how it affects the mass of this substance, which will come out as a neutral element or gas, as the case may be, at the end of the process. He found out something. He noticed that as he's increasing the mass, the quantity of the electricity from the current source, that the mass of copper that you are going to get at the end of the process will also be increasing. Take for instance, originally maybe 20 coulombs of electricity was passed across, right? And the mass of copper gotten after the electrolysis of what? Aqueous copper 2 sulfate or aqueous copper 2 tetraoxosulfate 6 probably was 10 grams. He discovered that when you increase that quantity of electricity, let's say up to like 100, at the end of the electrolysis, the mass of the copper is no longer what he got before, but actually increased. That led to the, exactly, that was what now made the man to do what? Come up with this law, the first law, which is stated as that the mass of an element discharged or deposited at the electrode is directly proportional to the quantity of electricity passing through an electrolyte. So you don't really expect, 20 coulombs of electricity to give 10 grams of copper at the cathode at the end of the day, and when you also pass more than such quantity of electricity, you are going to get the same thing at the cathode for copper. No. So the higher the quantity of electricity, the what? The more the mass of the substance deposited at that particular electrode. Okay, we're going to look at the mathematical expression and how we can actually calculate this. Because it is obvious, you cannot face WAEC, you cannot face IGCS, you cannot face JAMB and other examination bodies without seeing this. IGCS may talk about the theoretical aspect, but the A-level part, you will see the calculation. But for WAEC, for JAMB, for NECO, there is no exam in chemistry at this level that you will not find this topic. And the good part of it is that once you have understood it, it is very simple. Applying this first law, we're going to look at we're going to look at the mathematical approach and then solve one or two problems. At the end of this class, we shall look at generally questions from the exam guide, and you will see that once you have listened, those questions you will not find difficult. Now, let's go. He said the mass, okay, it is still electrolysis of what? Copper sulfate. Let me assume it is the electrolysis of copper sulfate we are going to use. Okay, now, imagine the electrolyte is copper sulfate, right? Okay, imagine the time given is 2 or 30 seconds, and the current is 0.4 ampere. Okay, before I use this formula, let me bring out or write down the mathematical expression of that law. It says that the mass, let the M represent the mass. The mass of the substance deposited at the electrode is the mass of the is directly proportional to the quantity of electricity. M is directly proportional to the quantity of electricity. The M there is representing the mass of the substance deposited at the what? Electrode is directly proportional to the quantity of electricity. So, when we remove the sign of proportionality, we have what? Equal sign, and the constant comes in, right? Before the quantity of electricity. Now, instead of using K to represent constant, we use Z. So we have M is equals to ZQ, where the Z or the Z is a constant called electrochemical equivalent. It's called electrochemical equivalent. The Z is called electrochemical equivalent. It's a constant. It is a constant called electrochemical equivalent. So, but what is Q? Q is what? Quantity of electricity. How do you calculate the quantity? Sometimes they will give you the quantity direct, while in other occasions they will not give it to you. They will give you current and the time. By the time you multiply current and time, you get the quantity. So Q is equal to IT. What is the I? The I is the current, which must be in ampere. While the T is the time, which must be in seconds. But the quantity of electricity itself, the unit is what? Coulombs. The unit is what? Coulombs. Coulombs. While that of the current is in seconds, current is ampere and the time is in seconds. So this is the mathematical expression of what? Faraday's first law. If you round up this, you are going to then get that mass is equals to ZIT. What is the IT? Quantity of electricity. What is the Z here? The constant. And what is the M? The mass. This is an expression for Faraday's first law of electrolysis. How do we solve problems under this law? Let us look at the slide. Look at the first, okay, look at the expression is already there. Mathematical expression is M equals to ZIT, where the M is the mass in gram deposited or liberated at the electrode. The I is the current in ampere. T is the time in seconds taken to complete the process. And the Z is a constant known as electrochemical equivalent. Okay. Now, having said that, we are going to look at some questions now. Let's look at the first question there. The first question says, calculate the mass of copper deposited at the cathode when 0.2 ampere of current is passed for 30 minutes during the electrolysis of copper 2 sulfate solution. As I said before, I was even trying to use copper sulfate. What we have on the slide is still the copper sulfate. Now, what are you going to use? What are you going to do? Copper is involved. It's a copper solution. So it's between copper 2 ion and hydrogen ion. Copper is less reactive than what? Than hydrogen ion. So it is copper that will be deposited at the cathode. So here, the question is that you should calculate the mass of that copper that will be finally seen at the cathode after the electrolysis has taken place. That is the question. Now, in the course of the electrolysis, in the course of the electrolytic process, 0.2 ampere of current was passed for how many minutes or how many seconds? 30 minutes. So with this information, we can now calculate the mass of copper that is deposited when this quantity of electricity is passed across, what do you do first? First of all, write the ionic equation that is actually happening at that particular cathode. We have established the fact that it is copper 2, and that is why they are asking you the mass of copper. So if it is copper 2 that is to be discharged, so at the cathode, we are going to have what? Cu2 plus, which is copper, which picks 2 electrons to give us what? Neutral what? Copper. This equation you must write. In WAEC, this attracts 1 or 2 marks. If you omit it, you will lose the mark allocated to that particular point. Because you cannot just start calculating without showing us the ionic equation. It is this copper that asking you, what is the mass of this copper? What is actually the mass of this copper? That is what they are trying to know. So what do? Follow the steps I'm going to use now. I will show you 2 ways you can calculate this. Now, you can see that 2 electrons balance this because the ion is 2 plus. So it will attract 2 electrons, so they can cancel that. Now, that number of electrons that can cancel out this positive is the what? The number of Faraday that is involved. The number of what? Faraday. So here we have what? 2 Faraday. 2F. 2 Faraday. Okay? Now, you relate it to the positive side. What element do I have there in the positive side? Copper. How many number do you find here after writing this equation? You have only 1, which is 1 mole. So it means that here I have 1 mole of copper. Taking 1 mole of copper to its relative atomic mass. What is the relative atomic mass number of copper? 64 or 63.5, approximately 64. So that means this 1 mole is the same thing as 64 grams. Because 1 mole of every element is equal to its relative atomic mass number. So 1 mole of copper is equal to what? 64 grams. Why? 64 grams is the mass number of what? Copper. So from here, you have established the fact that 2 Faraday will give us what? 64 grams of what? Copper. What is the unit of Faraday? Coulombs. So I have here now 2 Faraday, right? The unit of this Faraday is coulombs. So the next thing you would do is to find another quantity of electricity, which either they will give it to you direct in the equation, or they will give you the 2 things that you can multiply to get it. What is that quantity? Quantity of electricity is equal to IT. Remember, I told you the I is current in what? Ampere. T is what? Time in seconds. But if you watch what we have on the board there, we have that of what? Copper, which I have written. We have that of the time to be what? 30 minutes. So you are expected to convert the 30 minutes to what? To seconds. 30 minutes to what? To seconds. Right? When you convert that, how do you convert minutes to seconds? How do you convert 30 minutes to seconds? You multiply the 30 by 60. Because 60 seconds make 1 is equal to 1 minute. So we are going to multiply this. So what is our current first? Our current is how many ampere? 0.2. 0. What? 2. 0.2. So 30 times 60, we are going to get what? Convert the minutes to seconds. So 30 times 60. 30 minutes times 60, we are going to get 1,800. By the time you multiply these two, you will have your quantity of electricity. That means 1,800 times 0.2. What is 0.2? The current in ampere. the value will give us 360 coulombs of electricity. This is what is passed across during the electrolytic process. In some occasions, they will give you the quantity direct. But if they don't give you the quantity, what do? You calculate it. They will give you current, and they will as well give you what? The time it takes. If the time is in hour, still convert it to seconds. If it is in seconds, go on to use it like that. So what do? I have found that quantity, so my calculation now will come back. That from the balance equation of this ionic equation, I have it that 2 Faraday is to what? 64 grams. Don't forget how that 64 came about. Because here is 1 mole. And 1 mole is equivalent to what? The atomic mass number of copper. Right? Therefore, new quantity we calculated, which is 360. What mass in gram will it give us? Simple. Can you see how simple the calculation is? If it is understood. Where is the 64 coming from? It's coming from 1 mole of copper, because 64 is the relative atomic mass number of copper. So mass number of an element or compound is equal to 1 mole at standard condition. Now, how did I get 360? You have to calculate the quantity of electricity that passed across if it is not given. This one, it is not given direct. They gave us current and gave us time. So you multiply the two. That is how I got 360. Now, how did I get these 2? This 2 is the number of electrons that cancels out the positive ion here. And that attracts the number of Faraday that is involved. So how many Faradays do we have there? Now we have 2 Faradays. But 1 Faraday is a constant. What is 1 Faraday? 1 Faraday is 96500 coulombs of electricity. 96,500 coulombs of what? Electricity. So what happens here? What happens here? You have it now. We have established something. What did we establish? We established that 2 Faraday is to what? 64 grams. Therefore, 360 coulombs. This Faraday is also in coulombs. Is what? S gram. We are looking for this mass. So what do? Make the S subject of the formula. How do you do that? S becomes equals to, like this, cross multiply. You have 360 times 64, all divided by what? 2 Faraday. But the Faraday itself is 96500. 96,500 coulombs of electricity is equivalent to 1 Faraday. By the time you calculate this, you will arrive at the mass of copper deposited at that cathode. So can we do the calculation there now? We have 360 times 64. Here will give me 23,040, all divided by 2 times 96500, 2 times 96500, 2 times 9650 will give me 19300. So we can divide this to get our mass of copper deposited at the cathode. So what would the mass? Divide 23,040 by 19300. That means 19,300. And we are going to arrive at 23040 divided by 19300. We have mass to be approximately 1.9 grams of copper. So what is happening here now is that when this quantity of electricity, 360 coulombs of electricity, was passed across the electrolyte. Which electrolyte? Copper 2 sulfate solution. The mass of copper finally deposited as a chemical at the electrode, which is the cathode, is equal to 1.93 grams. What did Faraday say? Faraday said, if you increase this quantity of electricity, that means the mass of copper here you will get at the end of the process will also increase. Can we now go back to that law again? What did he say? He said, this is second. Let's look at the first law. Say, It said the mass of an element discharged or deposited at the electrode, in this case now, which electrode? Cathode, is proportional to the quantity of electricity passing through an electrolyte. That is first law. If you don't want to approach it like this, alternative method you can apply, or formula you can apply to calculate the mass deposited at the cathode is calculating the mole first. After calculating the mole, convert the mole to mass. Convert the mole to mass. So let's calculate the mole. Take note of this. How do we calculate the mole first? There is a formula I will give you. The formula is that the mole is calculated using IT. What is IT? Quantity. Okay, using quantity all over ZF. This time around, the Z here is not electrochemical equivalent. It's a symbol we are using it to describe the number of Faraday that is involved. So which is equal to, what is Q? Q is IT over ZF. Now let's get the mole. What is the quantity of electricity we got before? The quantity is 0.2 ampere times what? The time was 30. The time was 30 minutes, which will times 30 times 60, right? All divided by the number of Faraday. This Z is this number of Faraday, which is coming from the number of electrons that is used to balance the equation. So I have 2 here, then times F. F itself is the Faraday constant, which is 96,500 coulombs. By the time you solve this, that is mole. You now convert the mole to mass. Now let's solve this. Let's solve that. So I'm going to have 0.2 times 30 times 60. I have 360 over, then I have 2 times 96500. Below I have 19300. Whatever I have here is the mole. The mole becomes 360 divided by 19300. I will arrive at 0.01865. Let me stop here. Mole. This is mole. This is what? Mole. So, mole of what? Copper. So, convert the mole to mass. From my previous chemistry, the relationship mole has with mass, that mole is equal to mass over atomic mass number. So by the time I have mole, which is equal to mass, I am looking for, this is the mass I'm looking for now, divided by what? Mass number of copper, which is 64, right? What is my mole? My mole is this. So therefore, my mass becomes, mass is now equals to the mole, which is 0.0186 times what? 64. Let us see if we can get the same answer we got before. So this mole now, when you multiply this mole times 64, look at it, we got the same answer. So that's another method you can apply. Get the mole first. Which formula? Mole is equal to IT, which is quantity of electricity divided by number of Faraday times the Faraday itself. After that, convert the mole to mass. That is first law stated by Faraday. From this, you can as well calculate other components of that particular formula. You can calculate current, you can calculate time, you can calculate what? Quantity. It depends the one they want you to calculate. But this is the basic. If you can calculate the mass deposited, then any other one they're asking you there, you make it subject of the formula. You make it what? Subject of the formula. That is first law of electrolysis, stated by Faraday. Now, the second law. What does the second law state? After the first law, Faraday also stated the second law. In second law, he considered a situation where you have more than one electrolytic cell, where you have 2 electrolytic cells or 3, but the same quantity of electricity is passed across. What did he say? He noticed that if you pass the same quantity of electricity to 2 or 3 electrolytic cells, say it is the same quantity that the one that passed to the first one will be the same quantity that will enter into the second one. But he discovered something. He discovered that, okay, look at it. If you have 2 electrolytic cells, do you expect to work with 1 electrolyte? No. Of course, each of the electrolytic cells must have an electrolyte. Yes. The other one also will have what? An electrolyte. So imagine where you have 2 electrolytic cells. One of them contains copper. The other one contains aluminum. That is copper salt and aluminum salt. When I say copper salt, I mean copper as part of the electrolyte. It could be copper sulfate, could be copper chloride, could be copper nitrate, as long as it's a soluble ionic compound. And the other one may have aluminum nitrate, aluminum, just like that. So, what did he observe? He said, the moment current starts passing through, as long as the 2 electrolytic cells are connected with something called salt bridge, as long as they are connected with a rod or whatever, as long as there is a link between the first cell and the second one, by the time current starts passing through, you will notice that the same quantity of electricity will pass across. But he further noticed something. He noticed that between the 2 ions, the positive ions, any of them that has higher positive ion will have a lesser mole. That means the charge on the ion is inversely proportional to the what? To the mole. Or the relative number of moles of any of them is inversely proportional to the what? To the charge in the ions of the element. Take for instance, let's deal with second law. Take for instance, I have 2 electrolytic cells. I have the first one, I have the second one, then I have an electrode here, I have an electrode here. Now, an electrode here also and here. So here is connected to here, right? Then here now is connected to the source of current. So here is containing copper 2 sulfate solution, and here is containing aluminum nitrate solution. Now the question is, if what is discharged here is copper 2, of course, which will pick 2 electrons at the cathode to become neutral copper. And what is discharged here is aluminum 3, which will pick 3 electrons to become neutral aluminum. This is second law. He stated, once a certain quantity of electricity is passed from here, whatever that enters here will be the same quantity of current that enters here. Then what did he notice further? He noticed that between copper 2 and Al3, which one is carrying more charge? Aluminium. So the mole of aluminium, after the calculation, the mole of aluminium and the mole of copper, which one will be higher? So this one that has a higher charge will have a lesser mole. While this one that has a lesser charge will have what? A higher mole. So here now, the mole of copper will be greater than the mole of what? Aluminium. That is the second law of electrolysis. One question will be enough to take care of it. Now it says, when the same quantity of electricity is passed through more than 1 electrolyte, then the relative number of moles of elements discharged are inversely proportional to the charges in the ions of the element. Now let us see how we can calculate or do 1 or 2 calculations based on this second law. Now, let me have this to be what happens during electrolysis. It is between copper 2 sulfate and the copper. Now, the question is, calculate the mass of copper deposited at the cathode in the second cell if 3 grams of aluminium is deposited at the first cell during the electrolysis, or we can form it this way, on the first cell from copper salt and the aluminium salt. Look at the question. The moment 2 metals are mentioned, you should know that this is second law. 2 electrolytic cells are involved. Looking at this question, calculate the mass of copper deposited at the cathode in the second cell if 3 grams of aluminium is deposited at the first cell from copper salt and aluminium salt. So the first thing you do is have to write the ionic equation of both cells, both of them, using their metal. Now, take note of the question. 3 grams of aluminium was actually what? Deposited. So I'm going to wipe the board. 3 grams of aluminium was deposited. Now, where are the 2 ionic equations? Write aluminium 3 plus 3 electrons. That will take care of the 3 plus here. That gives us what? Neutral what? Aluminium. Now for copper 2 plus to take 2 electrons to give me neutral copper. Now we are told that 3 grams of what? Aluminium was deposited. So calculating from aluminium, which they have given to us, we have 3 Faraday from here, which is equivalent to what? 1 mole of aluminium. 1 mole of aluminium is what? Equal to the atomic mass number, which is 27. So 3 Faraday is equal to 27 what? Grams. Therefore, you are going to look for quantity here because they didn't give you current, they didn't give you time, and they did not give you the quantity direct. So you calculate the quantity. But we are told that quantity resulted to what? Deposition of 3 grams of aluminium. So here now, we're supposed to find, they are now asking you to do what? Calculate it. We're supposed to find here. So what do I have here now? 3 grams. That is in the question. When 3 grams of this was deposited. With this now, you are looking for the quantity. So what is the quantity now? Therefore, quantity now is you cross multiply 3 Faraday times 3 grams of this, all divided by 27. Don't forget that this Faraday is 96500. So we are going to have what? 3 times 96500, right? Then times what? 3 equals to all divided by 27. Okay? So the quantity of electricity there now is what? 32166.67 coulombs of what? Electricity. You are using the mass, the one that have given you the mass, to calculate the quantity that is involved. So this is the quantity of electricity that was actually passed across. So from here now, they're asking you to calculate the mass of copper. So if you can remember that the same quantity of electricity is passed across, then this question is solved. What do? Come up with what? The ionic equation of the copper. Let me write it again. I will come up with the ionic equation, which is copper 2 plus 2 electrons to give me neutral copper. What happens? This is 2 Faraday, giving me 64 grams of copper from 1 mole. Therefore, the quantity of electricity has been calculated, which is what? 32166.67 is to what now? X gram. We are looking for what? Mass of copper. And the question is solved. So make S subject to the formula. S becomes this. 64 times 32166.67 all divided by what? 2 times what? Faraday. What is Faraday? 96500. And your answer becomes the mass of copper deposited at the second electrode. The mass of copper deposited at electrode. So, with this quantity times 64, right, we are going to have 2058 666.67, then all divided by 2 times 9650, which is 193,19300. By the time you divide this, you get the mass of copper deposited at the cathode in the second electrolytic cell. What did we do here? Divide this, that will be the mass. What we actually did here is the mass of aluminum is given to you. So if it is given to you, use it and get the quantity of electricity that was passed across. Right? By the time you get the quantity of electricity, you should now remember that second law says that the same quantity of electricity will pass across, even if there are 10 electrolytic cells containing different electrolytes. Yeah. So you now substitute that quantity of electricity and get the mass of the other. That is the second law. That's how we calculate it. So what do you see? You can see the calculations are very simple. Right? Okay. Practice more. Pick up questions from ExamGuide. Solve. You will find out that these are simple things you can do, provided you have been following us. Thank you. Until I meet you in our next class, where we shall be discussing applications and the uses of electrolysis. Till then, bye.